Okay, so for the last part, we kind of simulated what happened in Desmos, where our first circle was kind of locked with its center on the y-axis. The tangent line was the x-axis, which allowed us to do our computations, which was fine. Since this is a geometric type problem, I like to have sort of as much openness to it as possible. So as a result, what I'd like to do is I'd like to actually draw a circle to be my first circle. And I'd like to go into these lines here and go down to tangent and do a tangent through point B to this circle. Boom. And sort of set up my sketch. And again, I'll do this by that. I want to set up my sketch so that I'm controlling the first circle by these 2 points and actually controlling the tangent line too, so that I can move things around. Now I'm going to still get the second circle, have its radius controlled by a slider. We'll go beyond that in the next part, but for now we'll do this. Okay, so same sort of deal. We know how far apart the points of tangency are. Now, what I'm going to do is I'm actually going to set up a function. So I'm going to set up a function of 2 variables, x and y. And the x and y are going to be the radii of the 2 circles, and the function is going to spit out how far apart the 2 points of tangency are, and we saw that that was 2 times the square root of the product of those 2 things. So I'm going to set up this multivariate function that's going to spit that out. What that allows me to do is, if I want to do this multiple times, I can just sort of spit it into the function rather than having to type this out. Okay, so I know that I can then find the distance to that second circle, so I'll call that D1, and it's just going to be D of the radius and first, before I do that, I haven't defined this R, so again I'm going to call big R the radius of this circle, and what I'm going to do is I'm just going to say it's going to be the distance from A to B. Oh, distance from A to B. So we can see over here, if I adjust those, it's going to adjust this, and I'm going to set my D1 to be D of R comma R. Okay, so that's telling me how far these 2 things are apart. Well, I've got my 1 point of tangency. I know my other point of tangency is that many units away, so I just need to mark a point along this tangent that many units. So again, since we're using kind of a geometric feel to this, we're going to use sort of a geometric tool. So just as if we were doing this on paper, if we were doing it on paper and we were measuring a distance, we'd use our compass to do it. We're going to use our compass or our circle tool here, using a circle with center and radius. I'm going to start from this point, and how far do I want to go along? I want to go along that D1. And this gives us all the points that are D1 along, but I want the one that's along the line. So where this circle crosses the line, there's 2 places, because of course I could put the other circle on either side. So I'm just going to go to my point, get an intersection, pick one of these intersections, right there. And that's going to be my point. And that's going to be the point of tangency. And notice that if I go and I change the size of this second circle, the point of tangency is going to move along. And where's the center going to be? Well, it's going to be, since this is tangent to the circle too, if I go perpendicular to that, the radius is going to be perpendicular to this tangent. So let's go to my lines and get a perpendicular line. I want a line that's perpendicular to this line through that point. And my center is going to be this many units from here along this line. So same sort of thing. Go to my circle tool, circle with center and radius. From this point, I'm going to go a distance of r. And where those things intersect is going to be my new center. Okay, and if we want, we can use the same sort of terminology that we used before. We can use the O. So if I go to this point, the object properties, or I could even just rename it. Instead of calling it A, I'm going to call it O sub R. And same thing with this point here. I can rename it O sub little r. Okay. And then I just want to finally do my circle that has, this is my center and little r is my radius. And now I've got my two tangent circles, right? Now I've got all this other stuff along the line. And here's where sort of having these things grouped by the type makes it useful. I see that this circle E was one of the ones that I used, and this circle H was one of the ones that I used. But circle C and circle K is what I want. So I want C and K, but I don't want the E and H. So I can just click on these things to hide them. Same thing with our line here. I don't want this line G. I do want the line F. So I go to lines, I can get rid of that. And now what we've got is I can adjust my first circle into more sort of organic to the circle way by those 2 points. And my second circle is controlled by my slider. And we can go through exactly the same process to find the third circle. I can set up another function. I'm going to set up a function n for new radius. Returning to the article, we saw that the new radius is going to be this expression, the product of the two radii over this. So if we go back and call this new function, here, let's get rid of this do. Let's try that again. So we'll call it n of x comma y is going to be x times y divided by, what was it again? X plus y, 2 root xy. X times y divided by x plus y plus 2 times the square root of x times y. That should do it. Okay, so I can find my new radius 3, r sub 3 is just going to be n of r comma r. So there's my r sub 3. How far, and now I just have to find out how far it is from either of these. So my d sub 3 is going to be this distance from the big one. And now the new circle has radius r sub 3. So r sub 3. And now we can go through the same process that we did before. I can go my circle. Oops, wrong type of circle. Circle with center and radius. I'm going to move over d sub 3. I'm going to find my point of intersection. I'm going to find my perpendicular line. I'm going to sort of hide things as I go along and get rid of that circle P. I don't need to have that anymore. Now I want to do another circle through there with a radius r sub 3. And what have I done wrong? Oh, no, that's okay. Okay. Intersect. And now I'm thinking I'm done, but I'm not done. There's my center, again, r sub 3. And there's my circle. I can hide this Q. I can hide that line. And now I've got all three of these things. Again, the first one is controlled by the 2 points, which is kind of nice. And it also allows us to move the tangent. The second one's controlled by this. And the third one is fixed by those two. Now, the advantage of sort of using the function notation is that now if I wanted to, I could actually go and say, oh, you know what? I want to get a new circle that's going to be tangent to these two. So that new circle, I could say r sub 4 is going to be n of, and it's going to be between the r and the r sub 3. So r comma r sub 3. So I get my n4. And my distance, d sub 4, is going to be the distance between the r sub, the big R, and the new one, the r sub 4. So I have my D4 and my R4, and then we could do exactly the same process. Circle with center and radius. I'm going to have this D sub 4. I'm going to find my intersection. I'm going to find my perpendicular line. I'm going to hide this perpendicular line. Oh no, I'm going to hide my circle. I'm going to do another circle, center, and radius. Now it's going to be r sub 4. Another intersection. Now I can hide this line. I can hide that circle. Oops, not that circle. That's C1, sorry. C1, I could hide that circle. And I could just do a circle there with r sub 4. And now I've created another one in there. So, and I could do this as much as I want. And just having those functions defined just keeps us from having to type out these big expressions every time with the new variables. So that's kind of neat. Now, in the next part, what we'll do is we'll actually involve a little bit more geometry so that we don't have to use these sliders.